Good morning and Jai Hind everyone. So in my previous video I gave you the basic idea of radioactivity disintegration law. So in this video we will discuss about disintegration constant, that is lambda, half-life period and the various units used for radioactivity. So let's start. Radioactive disintegration constant. dn by n equals to minus lambda dt. It was discussed in the previous article also. If dt equals to 1 second, then we may write dn by n equals to minus lambda. Thus, lambda may be defined as a relative number of atoms decaying per second. Again, since we know n equals to n naught e raised to power minus lambda t, where n naught is the initial number of atoms and n is the number of atoms at time t. If we take t equals to 1 by lambda, here comes n naught e raised to power minus 1. Minus 1 means it will come in the denominator. So, n equals to n naught by e. So, lambda may be defined as a reciprocal of time, means 1 by t, when n number of atoms reduces to 1 by e times its initial value. So in this way we can define the radioactive disintegration constant. Now half-life period. Half-life means half-life period is the time required for disintegration of a half amount of the radioactive substance originally present. For example, if suppose 10 atoms are present originally, to disintegrate half means 5 atoms, the time required will be half-life period. So the time required for the disintegration of half of the amount of radioactive substance originally present, if t is the half-life period, then n by n naught, we know n will be n naught by 2, half. So putting the value of here, we will get 1 by 2 equals to e raised to power minus lambda t, or we may write e raised to power lambda equals to 2. Taking anti-log both sides, we get lambda t will come in front and log e equals to 1. So lambda t equals to log e 2. Log 2 value is 0.6931. So t equals to 0.6931 over lambda, or lambda equals to 0.6931 over t. The time t in which material changes from n naught to n equals to, this is the basic formula. So for half-life period, you may use this formula to calculate half-life period if disintegration constant is given. So putting the value of disintegration constant lambda here, you may calculate that half-life period. Now we will discuss about units of radioactivity. So basically 3 units are used. First is Curie, Rutherford and Becquerel. It was, as you know, radioactivity was discovered by the Curie. So its unit is Curie. So Curie, the activity of the radioactive substance is said to be 1 Curie if it undergoes 3.7 into 10 raised to power 11 disintegration per second. So 1 Curie means 3 into 3.7 into 10 raised to power 10 disintegration per second. एक सेकंड में अगर इतनी 3 into 7 into 10 raised to power 10 डिसइंटीग्रेशन अगर हो रही हैं तो उसकी रेडियो एक्टिविटी होगी 1 क्यूरी. सेकेंड यूनिट इज रदरफोर्ड. द एक्टिविटी ऑफ ए सब्सटेंस इज सेड टू बी 1 रदरफोर्ड इफ इट अंडरगोज 10 raised to power 6 disintegrations per second. So 1 rutherford means 10 raised to power 6 disintegration per second. Third unit is the becquerel. 1 becquerel means activity of radioactive substance is said to be 1 becquerel if it undergoes 1 disintegration per second. So this is the basic conversion that you can use Curie, Rutherford you can change Curie into Rutherford by multiplying by 3.7 to 10 raised power 4, and 3.7 to 10 raised power 10 you can change into becquerel. So these are the basic unit that are used to measure the radioactivity of substance. So hence we have now discussed disintegration constant, half-life period, its definition, the formula used, units of radioactivity. So hopefully you have understood the topic, and still if have any doubt you can ask me personally or comment in comment section also. Till then, stay home, stay safe. Thank you so much.